Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome back to another video involving circles. As you can see, I have a circle drawn here, and we're going to be working on secant lines and segments. Now, we've in previous videos, talked about secant lines because a chord is a type of secant line. So you can actually use a secant line, ray, or a segment. And a chord, of course, would be a segment. But the entire point behind a secant line is they intersect the circle at 2 points. Whereas if you watch my video on tangent lines, you learn that it only touched at 1 point. So I'm going to go ahead and draw a couple secant lines here. So draw one in purple, extend it out, and we'll do one in pink. Now, what you might notice is that, yes, we did divide the circle up into 4 different arcs. And the angle created, now, you may not see it, but we actually created some inscribed angles here, okay? So I'll label this as B, and this is C. This is 61 degrees. And we'll call, let's see, I'll throw an A here and a D here. Yeah, just mix it up, right? Line AB, line CD. And I'll put an angle 1 here. The question is could I get that angle right there? Could I find it? And that can be a little daunting, maybe not. Okay. The other thing is we're going to make this one up here 155 degrees. Okay. So we can find several things out. So what you may not realize is that we actually have inscribed angles. I could finish drawing this triangle from A to the intersecting point to C, and I have a triangle. But if you look here, A is on the edge of the circle. So we know that we have an inscribed angle. So since this is 61.5 on the, or 61 on the arc, we know this is half of it, 30.5 degrees. Okay, we can also do that over here. Draw this inscribed angle, A, 155 degrees, right? So if I cut that in half, I get 77.5 degrees. And I could do this angle as well. So anytime we have these, we can look at our different angles created. Okay? So make sure that you pay attention to the fact that when you have intersecting arcs, you actually can do several inscribed angles. You can do one at each vertice, and it depends on which arc information they give you about that you can come back and you can look at other things. So that's the beautiful thing. Now, also keep in mind, you would have vertical angles as well. So you could pop back and use those as needed. Okay. So let's look at a theorem for what would happen if I gave you certain information. We'll go ahead and we'll walk through it with one example, and then we'll look at the rule for it. And I want to draw it the same both times. So I'm going to do a rough circle. And we'll do it once where we just call it the we'll give numbers, and we'll do it once where I give variables. And okay. And these are not going through the center. I'm going to put the center over here on both of them. All right. This top arc is going to be 80, and this bottom arc is going to be 50. Over here, we'll call them X and Y instead. Okay, so the 50 is the arc from here to here, right? Let me do my circle in green. That way we can always erase things as needed. And I want to look at what it does to this angle, or even this angle, because they're the same size, right? What does it do to that angle? So this 50 is the arc between here and here, which means it's this inscribed angle right here. So that puts 25 degrees in right there. Okay. Whereas the 80 is from here to here, which is this inscribed angle right here, which gives us 25, so 80 goes to 40, all right? Now, there's a couple ways we can get angle 1. We can use our remote interior angles theorem, which I'm betting you forgot. I'll remind you about it in a minute. Or we could find this angle first, and once we know this angle, we know that angle. Okay. So 180 minus 40 minus 25 is 115. So that leaves 115 for right here. And then 180 minus 115 is 65. So your remote interior angles say this exterior angle equals the remote interiors added together. So is there a better way to relate the 80? So we cut the 80 in half, we cut the 50 in half, and then we added them together, right? So we took the top and divided by 2, we took the bottom and divided it by 2, and then we added them together. Or you could say we average them. And that's what happens is when you have this arc here known and this arc here known, this angle, they're vertical angles, so both of them, notice that the arcs are on opposite sides of the X. They're not adjacent, they're opposite sides. So it's just the average. Arc plus arc divided by 2. So that's not too bad. So secant lines, now notice that they're not meeting at the center. They're not a central angle. They're not meeting on the edge. They're not an inscribed angle. So that's a third type of angle, right? Doesn't meet on the side, doesn't meet in the middle, doesn't meet on, it meets somewhere randomly inside the circle. Okay, we'll end up making a little chart here in a minute to try to remember them all. Okay, let's look at when I have two secant lines, because you know we have to do different scenarios. My compass kind of slipped off. My circle may not be very pretty here. Yeah, it's close enough. So that was when they met inside. So we still have another angle, right? We're going to have a secant line here and a secant line here. So this time, they're not meeting inside, they're not meeting on the edge, they're not meeting in the center of the circle, they're meeting on the outside. What has that done? Okay, so we're going to go ahead and say this arc is 100 degrees, right? And this arc is going to be 30 degrees. And remember, we need points at each of those spots. Okay, So we really got to think about where those inscribed angles are, right? So I can do this right here. Now, if I'm looking at this right there, notice my focus, I have an arc of 30, which means my inscribed angle would be 15. Okay. Or if I'm looking here, let's draw another line, because that's not the one I needed. Okay. We can do it that way. If I'm looking here, this is 100, so that would leave a 50 right there, because that's a relationship between the inscribed angle and the arc. But we also see a straight line right here. So in the triangle itself, if that's 50 degrees, this right here is 130 degrees. So what's left for this triangle right here? Well, 130 plus 15, we're at 145, right? 180 minus 145 is 35 degrees. Okay, so that's a 35-degree angle. How could I have gotten that with just the 100 and the 30? Well, when it met inside, we added them together, but now it's outside. So 100 plus outside 35. See how I used a negative? So that I kind of treated it the same. It's not exactly how the formula is written. The formula is written a little bit different. It does minus and then, oops, this was 30. What am I doing writing 35? Had the answer in my head, didn't I? And then we divide that by 2. Okay, so that was x minus y divided by 2 when they met outside. Okay, so what do we have? Let's see. Central angle. Arc degree equals angle degree, right? Inscribed angle. Arc degree divided by 2 is your angle degree. Okay. Secant lines meet inside. Arc 1 plus arc 2 divided by 2 gives you your angle degree. And so let's say your secant lines are meeting outside of the circle. That's when you're going to take your arc 1 minus your arc 2 and divide it by 2 to get that angle. So it really is important to understand what type of line you have, whether you have central angle inscribed or you have secant lines are meeting. So again, central angle must have the center involved. Inscribed is going to be using the side of a circle, whereas secant lines are either going to be clearly inside or outside. Okay, so what happens if we have a circle and we have that was not a very good tangent line, and a tangent line? Okay, they're still meeting outside of the circle. So you would still arc minus arc divided by 2. What if one of them is a secant line and one of them is a tangent line? It doesn't matter, they are still meeting outside of the circle, and so we're going to go ahead and use that rule. So let's pop up a couple circles here and let's see if we can't remember and apply these correctly. So I'm going to get my compass out and draw 2 quality circles, but I probably don't need them as big as I've been drawing them. Okay. Finish that circle out there. There's one of them. Okay, there's our second one. So here we have W, Y, and we're going to have X, Z. 107 degrees is going to be here. 74 degrees is going to be here. And we want to find the mark of the measure of arc WX. Okay, well, these meet inside, which means the angle at which they meet, which is 107, equals, now remember we're looking for WX, we're looking for this right here. I'm going to put a star right there. Okay, so that 107 came from doing the average of these two. We don't know it. And I didn't put a letter here because I didn't want to confuse you with solving for X, solving for Y, things like that. So I just put a box. Maybe you take it back to like elementary school, right? So prior to dividing by 2, we would have needed 214, right? And I could have put the measure of WX, but I didn't want to do that. So we subtract the 74, we find out 140 degrees would be that missing part. So the measure of WX is 140 degrees. If it helps you to put a box instead of a variable, that's an okay thing to do as long as you don't have several different things you're solving for. Okay, so here we're gonna pop this in and pop that in. We have 152 degrees here. We have 126 degrees here. We're going to call this R, Q, P, S. Now I find the measure of angle, PSQ. So that means I want to find the measure of this angle. Well, it meets on the outside. So it's going to be 152 minus something divided by 2. The problem is we don't know how big this arc is right here. Why did they even give us this 126? Well, a circle has 360 degrees, right? So we already have 126 plus 152, so we're already at 278 degrees. Well, helps if you type out your numbers, doesn't it? Leaving us 82 degrees right there. So this has to be 82 degrees. So this is 82 degrees. So 150 minus 82 is 70. Divided by 2 gives us a 35-degree angle. So location is really, really key. It's going to help us do that. So now let's find more relationships, because now we've kind of looked at all the ways lines can meet inside of a circle, outside of the circle, on the edge of a circle, right? So here I have a circle just with two segment lengths going ahead. They're secant lines, right? So I'm going to go ahead and do I want to focus on arc AB. Now, if I wanted to think about it, I could think of arc AB as being inscribed at C. Or I could think arc AB being inscribed at D. So because whether I want to look at it like this to get my arc or this to get my arc size didn't change, right? So because of that, we now know that this angle must be congruent to this angle because they are inscribed or 1/2 the size of AB respectively. Okay? The other thing that we now know, well, we've known for a while, is that vertical angles are congruent. Okay. So what do we know about triangle? And I need to put an E in here. CEB and DEA. Well, we've talked about two angles, so they at least have angle-angle similarity. Now, are they congruent? Not necessarily. Are they similar? Absolutely. So we do have to keep in mind that all these relationships are coming in. So they could be proportionate, we can solve, because all the corresponding parts are now congruent. Okay, so how's that going to look? And let's go ahead and play around with that. Okay, so we would have triangle CEB is similar to triangle. Now since I did the 1 mark, 2 mark is not marked, I'd have to start with D to E to A. Now let's go ahead and let's say we add some numbers to this. BE is 4, AE is 6, CE is 5, and DE is unknown. We want to find it. Okay? Well, let's look at the three sides here. We could do C to E, we could do C to B, or we could do E to B. The three sides here, we could do D to E, D to A, or E to A. Those are our three proportions. Remember, they're not congruent, they're proportionate. Okay, well, we don't know anything about DA or BC. So we don't care about this middle one here at all. However, C to E is 5, D to E is X, E to B is 4, A to E, sorry, this should have been, yeah, E to A, sorry. I don't know why I had double letters there, AA. So we had 4 to EA is 6. So we can see right here the proportions popping out. 4 is to 6 is 5 is to X. That's what we have here. So now that we do that, we cross product. So we get 30 equals 4X, and then we can solve and find out that X equals 7.5. So using the inscribed angles allowed us to create triangles and allowed us to actually see proportions. Can you draw that every single time? Yes. Is it good to write out your triangle similarity statement? If you're not seeing these things off the top of your head, absolutely go ahead and do that, because it makes you stronger at this stuff, drawing it out, seeing your relationships, comparing apples to apples. Instead of worrying about extra rules, you can fall back to your inscribed angle rules and your triangle similarity statements. Okay, so when they met inside, it was pretty easy to see our two triangles, but when it's meeting outside, maybe we don't see our proportionalities as well, right? So I'm going to actually give us variables this time so that we can see it. All right, so we need to create some similarity statements and figure out what's going on and all that good stuff. So I'm going to go ahead and connect C to E. And I'm going to connect B to D. Now we'll notice they connected to the same arc. So this angle and this angle are congruent. Now if we look, we can also see that angle E here has an arc CB, but we're not really wanting to look at that triangle, but there's a reason why I'm going to mark it. Okay, we don't have to, but we can. Okay, so that has the arc CB. The other one with an arc CB is right here. So this small triangle and this triangle here have angle-angle similarity. But those aren't the two triangles I'm wanting to look at. So let's highlight the triangles I'm wanting to look at. I'm really wanting to look at this triangle and see your focus gets drawn a different way. And sometimes you have to stop and think, is that the triangle I wanted? And those angles were not inside the triangles we were looking at. If you'll notice, they share angle A. And then they have that congruent angle. So we have angle-angle similarity just because they share A, and we've already marked these as similar. So the green triangle, A to B to D, is similar to the orange triangle, A to C to E. Okay, and our congruency statements are proportionates, right? Our three sides are AB, BD, and AD. Over here, our three sides are AC. Let's see, we did BD, so CE. And instead of AD, we'll have AE. Now, if you'll notice, BD and CE, we don't have anything about, so we're not going to use those right now. Okay, so A to B. A to B is this segment P and the segment Q put together. So P plus Q. A to C was M plus N. A to D was N. And A to E was Q. So it was the entire sides compared together and these compared together. Another way I've seen it written, same idea, just different, right? Is they've done N is to P plus Q as Q is to M plus N. And if you check out the cross products of those, you're going to be multiplying the N times the M plus N. You're going to be multiplying the Q times the P plus Q. So either way of writing is actually correct, but it's the outside. Q would be outside, right? Being multiplied by the sum, because that's what your product would be. Equaling outside multiplied by the sum. So if you're looking at that cross product, the first one would be Q times P plus Q, outside times the sum, right? And N times M plus N. So again, this is one of those times where maybe going ahead and writing the actual statements down so that you can see the relationships is better for you. Maybe you're a person who remembers these rules. I definitely think finding my congruent triangles is the safest backup because it can get a little bit wonky with all these relationships going on. So keeping with the theme of making sure that we check out our triangles, let's first go ahead and note that we could connect Q to R. And that would have an inscribed angle right there. And that inscribed angle goes with arc QR. Or I could connect over here at S, and S would also have an arc of QR. So that tells me that those angles happen to be the same. Once again, we share angle P, and by sharing angle P, I'm talking about this triangle right here versus the entire outline triangle. So again, they're not congruent, but they are similar. They are proportionate, right? So in the small triangle, we would have triangle Q, P, R, and that's going to be compared to triangle S, P, Q. So now we can look at our proportional statements. Do we know, so our three sides for the first one are QP, QR, and PR. Our three sides respectively. Instead of Q, we use S, right? Instead of P, we use P. And instead of R, we use Q. Those are our proportionality statements that we need. Okay, and we're going to be solving for A. Okay, so Q to P. Q to P is 6. S to P is 9 plus A. Q to R, I don't know anything about, and I really don't know anything about S to Q, so I won't worry about that. And P to R is A, and P to Q is 6. Now you might go, well, this isn't like the last one where we did, so let's go ahead and do our cross product. So we have 6 multiplied by 6, and A multiplied by 9 plus A. And sure, this looks like the outside times the sum, but this just looks like the outside times the outside, or is it? Couldn't this be written as 6 plus nothing? In fact, it is. It's exactly what it's supposed to be. It's still outside times the sum. So out times the sum, so A times 9 plus A, 6 times 6 plus 0, because there's nothing that goes through the circle. And you can kind of think of it like that. But again, we drew our triangle congruency statements and it just pops out to us. So all because of these numbers and our triangle congruency something. All right, so we've got 36 equals 9a plus a squared. So 0 is going to equal a squared plus 9a minus 36. And we're going to solve that by factoring. So a plus, let's see, 12 and a minus 3. If you don't remember how to solve by factoring, go ahead and make sure that you go back and check out one of my factoring videos. We'll come to this example in a second. So a will either equal negative 12 or positive 3. Now, which one of those makes sense in our scenario? If you said 3, you are correct. So our final answer is a equals 3. Okay, now I said that we'd come to this example in a second, and that's because, again, we can do our similarity statements, or you can just memorize how it went. I, again, am going to do similarity statements. So we've got our vertical angles, right? And if I connect this, whoop, we can connect like that. A little bit helps us, right? But think about it this way. It's probably going to help us to connect like this. Now I have arc. So arc BC is right here. Bloop. Or right here. Bloop. So A is matching up to D. E is that vertical angle, right? So it'll be in the middle. And this other triangle is B, or other corners B, and down here is C. And I'm talking about the bottom one and the top one. Okay, so do I know A to E? Yes, it is 4. Do I know E to B? Yes, it is 8. Do I know A to B? No. D to E is 5. E to C is X. There we go. There's our proportionality statement. For X equals 40, so X equals 10. So feel free with all those to go ahead and make yourself note cards if you want to memorize the formulas. Me, I'm all for drawing the similar triangles, finding the CPCTC, right? The corresponding parts of congruent triangles are congruent. But this is the corresponding parts of similar triangles are proportional. And I like using those proportionality statements because one, it goes ahead and relates it back to something you've already learned. But can you see the proportions existing right here? Absolutely. When it meets inside, you can just make a proportion. Left sides make the one, the right sides make the other. And if it meets outside the circle, remember it's outside times sum equals out times sum. So memorization works, or going back to those corresponding parts, you get to choose.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.